And then x to the 4/3 times x to the 8/3, that's multiplying common bases. That will become x to the what power, Trista? There's no Trista in here. Sarah Shelley. X to the, 12/3. Very good, which is 4. Yep. Good. Did I make you nervous with those fractions? Good. On this next one, we've got to, again, kind of see the structure first. So we can't just go ahead and multiply the x in the 2/3 times the x to the negative second, because multiplication does not come before exponent. So this set of parentheses, the fact that it's being raised to an exponent, that has to be addressed first. So that would be the E in PEMDAS. And then once you have that done, then we can go back and multiply. So I'm not going to touch this first term, x to the 2/3 y. And then x to the negative second to the 1/2 is what, Lydia? X to the what? -1, yep. And then y to the 1/2 is just y to the 1/2. Then we'll go ahead and do your common bases and add them. Now, 2/3 is what it is. -1 can be thought of as -3/3, right? So 2/3 and a -3/3 would be a -1/3. And then this y is technically being brought to the first power. That can be thought of as 2/2. 2/2 here plus 1/2 here would be 3/2. And then we'll just move that x to the denominator. So your final answer would be y to the 3/2 over x to the 1/3. In C with coefficients, you want to treat them and reduce them per usual. So 32 over 16, they both have a factor of 8. So if you divide an 8 out of both of those, you'll get, 16, right? So divide a 16, you'll get 2 over 1. You don't need the over 1. And then 5/3 minus 3/4. Now, if you didn't have a calculator, you'd need to get a common denominator. Because you do have a calculator, I say why not use it. So 5/3 minus 3/4, and you all should know how to do math fraction to get it back into that fraction. So 2x to the 11/12. Simple enough? Okay. All right, so this kind of looks immediately to me a little bit like our homework quiz. First step, Sarah Davidson. Flip it. Yep. So we'll have y to the 2/3 over 2x to the 1/3 cubed. And then take this term by term. So y to the 2/3 to the 3rd power. Power to power multiply. 2/3 times 3 is just 2. So that's just y squared up top. A base of 2 to the 3rd power is going to be 8. And again, x to the 1/3 to the 3rd power to power, you multiply 1/3 times 3 is 1/3 of 3, which is just 1, so we can just leave that as an x. E is just common basis, so we're just going to cheat with our calculator. 1/2 plus 1/3 plus 3/4. And here's where I'm saying, you're not going to write x to the 1.583 repeating power. You're going to change. You son of a gun. Thank you. 1/2 plus 1/3 minus 3/4. Okay, we're not just going to leave it as a decimal because it started in fractions. We leave it as fractions, so just to the 1/12 power. Those of you who had the hills last year, did you use a calculator on that? Or would you? Yeah, you would. They said calculator. Okay. All right, and then there's no F. So that's it for the exponent rule review just with fractions. Now kind of what a fractional exponent really is, because Ryan brought up a great question yesterday and we started talking about you can't multiply a base by itself -5 times, right? 2 to the 5th power, you multiply 2 by itself 5 times. 2 to the -5th power, you can't really logically do that. And fractional exponents would be no different. How do you multiply 64 by itself a half of a time? So that whole base knowledge of what an exponent really means to do, it kind of goes out the window. So, you know, I don't really ever use this one at all because this just kind of covers all circumstances. So anytime you have a base to a fraction, the denominator of your fraction is the whatever root you're taking. So if it's a denominator of 3, you're taking a cubed root. If it's a denominator of 4, you're taking a 4th root. That is actually called the index. I don't know if that's a word you know. Has anybody ever heard that before? If you're asked what the index of a radical is, it's kind of the number of the root that you're taking. So that's the index. And then the numerator is just the power on the base underneath the radical. And what you see here is actually that it can be done in either order. So you can, based on the way this first one is written, you would raise a to the m power first, order of operations, and then you would take the nth root. The way this one is written, you would take the nth root of the base first, and then raise that new base to the m power. So the reason this can be done really in either order is because if you think about your power to power rule, a to the m to the 1 over n. Everyone see how I split up that exponent? And rather than having it be one exponent, I made it a power to a power. So the way this one's written, you'd raise it to the m power first, which is what they're doing, and then you'd raise it to the 1/nth power, or take the nth root of it. If you do it this way, you're really raising it to the 1 over n first, and then raising it to the m power. And it's important to realize that it can be done in either order, and also understanding why, because power to power being multiplication can happen in either order. M times 1/nth is the same as 1/nth times m. So even though I know you guys have a calculator, I got to double check with Mrs. Fraser, because this would be a silly thing to allow you to use a calculator on, because you just type it in and you would lose the skill. But the idea is on A that if it's 64 to the 1/2 power, the index is 2, so it's the square root of 64 to the first power technically, which is just 8. Now that one I know you guys probably know pretty well, because you immediately see to the 1/2 power, you think square root, so that's fine. But B, if you're raising something to the 2/3 power, again, pretend like you don't have your calculator here. Would it be easier to do -27 squared and then take the cubed root? Or would it be easier to take the cubed root of -27 first and then square the answer? The second one. So when and again, my advanced pre-calc kids can't have calculators. So when I teach this, I always do teach, take the root first, because you're going to shrink it before making it explode. And if you tried to do -27 squared, you'd have to do a whole long laundry list of like multiplication. And then you'd have a humongous number, and you'd be trying to find the cubed root of it, which doesn't really work out. So you'd want to go this way with it. And the cubed root of -27 is -3, and then squared is 9. So you could check that in your calculator, that -27 to the 2/3 power is 9. Okay? On C, we're going to handle the negative exponent first. Okay? I should mention that on your homework quiz, I did see a couple of people give me a negative answer of -27. So to me, their thought is that if it's a negative exponent, we should have a negative answer, and we know that that's not true, right? Negative exponents just make a really small answer, hence 1 over 27 that we have here. 1/27 is a pretty small number. So let's take care of that negative first, just by moving this to the denominator, 1 over 81 to the positive 3/4. And then again, we're going to take the 4th root of 81 first, then we'll worry about cubing it. So the fourth root of 81 is 3. 1 over 3 cubed is going to be 1 over 27. Any questions? Okay. And the last thing on here with radicals says reducing the index. So if you hadn't already heard of that word, you were going to see it anyway. So whenever you're taking a root of something, in this case the 9th root, you essentially with a variable are looking for that exponent to be divisible by 9, right? Let me just see. You guys all know if we were doing this, right, you're looking that 9 goes in there one full time, right? So that would be x with how many left over? 1, right?
Okay.
9 goes into 10 one time with just x to the first left over. So if that's bigger than your index, then you can always simplify and take something out in front. However, in this particular case, it's significantly smaller. And not only that, we're still being asked to do something with it. So the idea here is to use this knowledge of your fractional exponent, change this to x to the 3/9, and then because we do know how to reduce fractions, 3/9 is 1/3, and then we can go back to the radical and just call this the cubed root of x. So that is known as reducing the index. The index was 9, now the index is only 3. Okay? And you may begin to just visualize this. This is going to be 3/6, and 3/6 is going to reduce to 1/2, and so that's just going to be the square root of x. And so on the last one, initially this is x to the 5/15, y to the 10/15, and we'd reduce x to the 1/3, y to the 2/3. And as long as those denominators are still the same, we can overall write this as the cubed root of x to the first, we don't really need the first, and y squared. Good? All right, so fractional exponents, radical stuff coming out. You're gonna do the odds again.
There's menus last time.
What's that?
There's menus last time.
No. Three. Yeah. Yes.